Hello, everyone, and welcome back. Let's jump straight into our demo environment where we were working on the DB utils to handle the files on the DataBricks file system. And like you can see, if I run it now, we have all these files sitting into the table folder. And what I have done, let me quickly recap. We have displayed these files which are sitting in here, and we can see we have a bunch of files sitting into this folder. Excuse me. And now what we need to do, obviously, it's looking quite unmanaged. We want to move it to another folder. And by the way, if you want to create a new folder in the DataBricks file system, there is a command that you can use it. And let me just show it to you. If you want to remove it, remove a folder, it's very simple. Let's first remove the existing folder and then we create a new folder. And I think we were in here. I think I moved back into. So let me just go to the data and let me go to click on create table and go to the file system. And now, like I mentioned in the tables, because all our files are sitting in here, we have two folders. We have IT equipment, and then we have the human resource folder. What I'm going to do, I'm going to remove this IT equipment folder because it has nothing, and I'm going to recreate a new folder and then put all these part file into that folder. So that's the exercise, because that will literally clean my subfolder under the table, and at least I have a proper manageable file hierarchy that I can later on use for my work. So let's come back, and now what we are going to do first. We use the same thing, DB utils. We are going to use FS, and then we are going to use RM. So let me show it to you. I think that's the better. And by the way, if you want to see the commands, the full list of commands, like I mentioned, you can press Control plus spacebar, and it will show you the command. So I think we are going to use a couple of commands in this one. I'm interested in RM, and RM is more like, if you remember Bash shell scripting, it is used for removing the files and directory. So in here, because I'm removing the directory, and directory is already empty. If I remember correctly, normally at the Bash level, if you need to remove a directory, that directory needs to be empty. Otherwise, you need to have to provide the recursive flag, so it will remove everything within that directory. And it's always a good thing to get some help before we use the command. So what I'm going to do, I'm just going to type RM into my helper function, and I'm going to use, press enter. And now I have a help available. Okay, so what it's saying, it has the string, which is obviously directory name, and then it has the recurse flag, which is available for us if we want to remove everything within our directory. So what it's going to do, it will go into that directory, it clean it up, like it remove everything. But if the recurse flag is going to be false, it won't remove anything which is sitting in the subdirectory within that directory. But if we want to clean everything, including the subdirectory, we're going to use the recurse flag. So what I'm going to do, I'm going to use the recurse flag, although I know my directory is empty, but just just for the sake of demonstration. So the file name which I'm actually looking, sorry, folder IT, yeah, equipments, and then I think that's the right one. Once you learn 2-3 syntax, that's always happen. Now I always confuse between single quotes and double quotes. Now that's better. And then we are going to provide true, right? So that's my my folder IT equipment. I want to remove that folder completely. And if there is anything placed within that folder, that will go on as well. So let me just run this command. Yeah, so looks like it didn't complete it. Let me just run it again. See, that's the problem. It's really hard for me okay. So it looks like it has gone. So the folder has been removed. So let me come in here. Normally, if you just click on that and then come back, I think it will remove it. No, it's not. Okay, hopefully now it will clean the cache and we can see that they're still there. That's why we are getting false. Let me see what was the reason. You know what we can do? We can IT equipment. Mostly we get the false if the folder name is not correct. So IT. My bad. I have actually typed the wrong spell. I'm very bad in typing the spell. So what I'm going to do, let me copy it from here because I've already copied it. Yeah, so that's the folder I'm going to delete. So the error is why it's returning me the false. False means it didn't execute the command successfully. Remember, guys, whenever you are getting the result as false, that means there must be some problem. It can't be a syntax error because if it has a syntax error, you have seen there's a red sign in here which shows you the error. It might be a logical error like you are providing an incorrect path, right? So the command will execute successfully, but it won't actually finish the operation. That's why it is returning us false. Now let's run it. Hopefully it will return. Excellent. So now you can see the folder has been removed. So now if I come back in here and let me see, it should remove the awesome. So now you can see the folder has gone because it has refreshed the view. Now what I'm going to do anyway, the spells were incorrect, so I'm just going to correct the spells now, right? So that's the folder we are going to create. So what we're gonna do now, let me just so instead of RM, I'm going to use mkdir. So what it does, it will actually create directory within that file system. So what I'm going to do, I'm going to create a folder within the table because in that folder, I will copy all the part files. So I have already correct the name. Let me just remove that. And like I mentioned, as usual, if you are new or if you just want to, on the safe side, if you want to change the syntax, just put it in the help function and look at the syntax. It will provide you the syntax as well as example. So you can see we have mkdir means if you want to create a full table structure, you can even do that. Like if you want to, instead of creating one folder, if you want to create one folder within another folder, you can do that as well. That's why it's not mkdir, it is mkdirs. So we are pretty good. Like we have at this stage, we only need one folder. So we are fine with this command. So let's run this one. Okay, so the result is true. Why I'm going back and forth in here because it's easily to view the new folder in here. So you can see now we have a new folder, IT equipment. So we are pretty good up to this point. We have created a new folder. Now what we are going to do, remember, we are going to copy all these files within that folder just for the sake of arrangement. So we have all these files sitting because remember in our real environment, these files can be 1000s, right? I'm going to show you how smart the DataBricks is, how efficiently it reads all these files and construct the outcome in the data frame, which you can later on convert into a SQL table or even the view. So you can run all kind of transformation and SQL operation on that. Okay, so the file system the folder is ready. The file system is ready for digesting all the files. Now coming back to our fancy function, which we were discussing previously, and what I'm going to do, because now we are ready, I'm just going to copy this function and I'm going to bring it in right underneath so I can keep these two things together. Excellent. And let me just copy that path because, safe side for me, that's my target folder, right? So what I'm going to do, I'm just going to copy this as a target folder, and let me explain that function. This is typical programming. Obviously, being a data engineer, you need to know the programming. That's for sure. If you are not comfortable with programming, don't worry about it. You don't need to be a hardcore programmer. It's more like a part of your skill. So data engineering is composed of many skills. One of the skill is doing the programming or development, right? Because that's part of the job. You are wearing multiple hats. That's why data engineering is gaining so much momentum in the industry, because it doesn't contain one skill. You need to be not expert, but you need to be good in the SQL. You need to be good either one of the language like Python, and I would say Python because Python is more like such a language that it can do all kind of workload, right? But if you know more than Python, like if you are comfortable with Spark, if you are comfortable with Java or C, and you have already seen that why we are asking C, because then it will help you to easily cover the batch scripting, which is really good if we want to write the script that can interact with the file system, and that's where the whole arrangement comes in. And sometimes what normally happen once we are building the pipelines within the DataBricks. So for example, imagine you get a bunch of files, a batch comes in, you read it, you apply the transformation or all kind of logics, you prepare the data and you push it to the target container, which can be another database, which can be even Synapse built-in database pool, which is more like a data warehouse, or it can be even a Parquet file on another folder within the same system, or maybe into Azure Data Lake or AWS Data Lake, which is S3, right? Then the last step is to move these files to the archival area, because you have already processed this file. If these files keep sitting there, it might confuse the people who are actually looking at the folder, that maybe these files are not processed, right? So maybe someone mistakenly reused these files. So that's why it's always a good practice to once the files have been processed and we use them, we move them to another folder. By knowing the programming language, these things really work well during pipeline building, right? So you can slowly learn it, right? It's not like you're gonna learn within 1 or 2 months, but more you work in the data engineering, more you're gonna actually get the command on these skills, right? Because practice is a key for everything. Now, coming back to our routine that we have written. So we have defined two variables. One is source folder and second one is target. And just tell you the truth, why I love Python than the other languages. It's very flexible. Like I don't need to worry about, syntax. I can't do this within the Spark or I would say C, C# or Java. They are not gonna let me go anywhere. That's how strict these languages are. If you're gonna miss the semicolon, if you're gonna miss the lower and uppercase convention, the meaning will change totally to a different term, right? So that's where these languages are highly, I would say, standardized or pattern oriented, right? Compared to them, Python is very flexible. It is more like, we call it a flexible potato, like it can adjust with any kind of, coding pattern. And that's why sometimes you're gonna see really bad codes written in Python, but they were doing the job, right? That's something you need to understand. And many people, once they go and they start working into the new enterprises and they inherit the code, never ever think that, oh, this code is not providing any value. That's a very negative thinking, right? About someone's effort who he maybe didn't put 100% into it, but at least if that was working for the organization in the past, that means that has a respect and that has a value. You need to enhance that value, right? Instead of reinventing the wheel. That's another mistake we need to avoid. Now in these days, please don't reinvent the wheel, because we need to, if you want to be successful in the data engineering, you have to stand on the shoulder of giants. And what does it mean? You have to reuse the work that has already been done for you, right? Because don't think that if some problem is coming towards you and you are building some really fancy solution, that solution is going to be unique. There are very rare scenarios where you can produce such solution, and those areas are definitely worth to put your effort on. But before you go into that mode, try to find out that if there is any existing solution, because what it will help you, it will help you finish that, gain that experience, and move faster towards the next level. And that will really boost your profile in the data engineering field, and you will see how quickly you can gain the skill and experience using that technique. All right. Enough discussion about the programming skills and the pattern. Coming back to our procedure that we have built. I have declared these two variables. The source one is containing the source location where our files are sitting, and the target is going to be where we are moving the file. So let me just move the. So let me remove the IT equipment. So that's my source folder, because all my part files are sitting in here, and I'm going to move them into IT equipment folder. And obviously, like I mentioned, we can get the files, all the file information using the ls command. So instead of displaying on the screen, I'm storing it in the file system. So you can see Python automatically, based on the return type, it's going to define the data type of files automatically. That's where the beauty of Python, and that's why Python is so popular and it was evolved so quickly, because it is taking a lot of load by itself, and all you need to just define the main skeleton of your solution and leave the rest on Python. Python will handle it. You don't need to worry about, oh, it's going to be string, I need to define. Just define the variable, and whatever the return type, the variable will be changed to that type automatically. And now, like I mentioned in the previous video, we are going to iterate to all the values, because obviously we are going to get the list of the file, because normally once we read a directory, it's not like a one file. We have multiple files, so that's why we are iterating on the list. And like I mentioned, in Python, you can use for loop and then you need to define a variable. And I'm also again going to change. And this time I'm going to change it to a completely different variable. So you can see I'm using V. And by the way, it is the DataBricks itself is because I think the default language is Scala. Scala is case sensitive. So if you are using a small case and you are later on using a capital case, these are two different things, right? So remember, in the Scala case, Scala is also, and Spark itself is also, because Spark is written in Scala, so they are case sensitive languages. Python is not. Python, you can write any kind of expression. It won't mind of the case sensitivity. All right, so I'm going to read each file from the list of files, and again I'm going to check the name property of my file. Have a look, read this way. If the name property of my file is starting with part_000, because all those files which are sitting there and have a JSON extension, they are starting with this phrase part underscore 000, and then we have the file number, and then we have the GUID, and then we have extension. So what we are going to do, we have the target folder. We are going to move that file towards the target location. By the way, once we read the file, what happened, it won't actually attach the full path. So that's why we need to concatenate the path again. Otherwise, the move function is gonna give me the error, because once it look the file name, it won't be able to identify the full path. So in order to move the file, and once we specify the source location, we need to define the fully qualified path. So what will be the fully qualified path? The file name itself. And let me just change the, I think that's much better. Yeah. I'm just changing the variables. I did it purposely so we can see a completely new picture in here, right? So what I'm doing in here, like I mentioned, after checking the condition, when I'm reading the file name, it is not giving me, it's only gives me the file name, not like a fully qualified path, but I want to see the fully qualified path, because fully qualified path means that include the path, because that will help the move command. And like I mentioned, move command used to move the file from one location to another location. We have seen the syntax earlier. Right, so we are going to use move command, and it requires the source location, and that source location is the combination of the source folder plus the file name. So that will constitute the source location or source folder, and then we are moving them towards the target folder, which I have already defined it on the top. So we are moving to the new folder that we have created. So now our routine is ready. I do believe it will work. So let's run it. So you can see the command has started, and whatever file it is moving, guys, it is spreading the, it is showing them on the console. So you're gonna see all these files they are moving from, because I used the display command to print those files, which it is moving from one location to another. So just let it run. You can see it is taking a small time because it is moving the file from one location to another, and it really depends upon the cluster and the load, because these are the shared cluster. Remember, I'm using the community edition. It's not like I have a dedicated cluster, because in order to do it, I have to pay it. And normally in our pure development environment, we have these sort of arrangement. So don't worry if you are not happy with the performance. Once you purchase DataBricks instance, you're gonna have a very, very good performance. It's all about paying DataBricks some good money, and you will get your desired performance. So you can see we have a bunch of files which are now moving from one location to another, and we can see the output. Let it finish. Hopefully it won't take much time. And you can see we still have the status running command. You can see the good thing, as soon as it's finished, you're gonna see the status has been changed on the top. Like at the moment, if you are even not seeing the progress of displaying file, at least you can see in here that on the top of the output window, you can see there is a 3 dot which actually showing the progress of the command, and it will disappear as soon as the execution of the command has finished. So we're just waiting for it to move all the files. And now you can see that status has gone because the command has been completed. Now coming back, so it's now verification time. Let's first run this one, our source folder. Now it should be very clean. So now you can see we only have some couple of files. The good thing, we move away from very clunky view towards a nice, arrange folder structure where we can only see a couple of files, and even these files we can move away. And by the way, later on we're gonna see how we can convert from one format to another. That's going to be another very interesting exercise, guys, where you are getting all this data and then you can, using DataBricks, you can convert it into desired format. And especially the Parquet format, which is very optimized in term of accessing the file through Spark. So these transformation or transition are all possible within the DataBricks environment. So now what we're going to do, for those who likes the user interface, GUI, let me just click back on table, and you can see all the part file, they are disappeared from here. So now if I click on the IT equipment, I can see all my files are sitting in here. In order to, there's another way to see it. If you like to write through the command, what I'm going to do now, I'm just going to I've created equipments. Hopefully I'm not mistaking this time. And let me run it. So you're gonna see we have all these part files available in here. Now, before I conclude the video, let me just read this file. I just want to show you where we are going to use these files, right? So we have all this data sitting into our folder on our cluster. I have actually downloaded one of the file you can see in here. I have downloaded it in the earlier before recording this video, and I moved it to a different location. And let me just close this one because I want to open it again. So let me just go and open a file. So that's the file. You can see one of the file I have actually loaded just to show you the content. That's the JSON based data. So now imagine we are going to read the data which is coming from, for example, from one of the device, and you can see it is more like a sensor data which we are receiving from some location, and we have these three elements of the three different dimension of maybe the location, but you can see arrival time, creation time. That's all the attributes which is sitting into that JSON file. And we don't have only one, so you can see the data is itself it's a very big file, right? Because each file is containing maybe, so this one has 78,000 78,011 records, right? And we have a bunch of files. What we are going to do, just to showing you the schema and the record. And by the way, in the JSON format, we have how the records have been arranged. They are arranged in a row, and each row is constituted of the key value pair. What key value pair mean? It's more like the column and the value are attached to each other, separated by column. So you can see in here, arrival time is the column name, and then we have obviously column, and then we have the value of the column, and the same pattern goes on. By the way, it's more like related to NoSQL concept, where we are going to violate a lot of SQL principle, or I would say data modeling principle, especially from the third normal form perspective. And we'll see how it will provide us more and more capabilities once we violate this principle into day-to-day life, right? Not a discussion at this point in time, but just to give you the idea. Now, something interesting before I conclude the video, I would like to do. Let me come in here. And I'm going to read all these JSON data. And now imagine we don't know how many data files we have, right? Even though, I can quickly write a routine. And that's where the beauty is. If I want to know how many files we have into this folder, what I'm going to do, bear with me. I'm just going to show you something. Let me use this cell. Okay, I'm going to find out how many files I have into my folder, and I'm just calling because I only need one folder, so I'm just calling it just source folder. So let me show you how we are going to do it, right? So we are getting all the files in here, and I'm going to just, let me just count is equal to 0, and I'm going to use count plus, and I'm not going to use this if condition anymore because I don't need to. I know I will only place the part file in here, and this display, I'm just going to put it because indenting is key in here. If you want to put outside of the for loop, you need to put the next command on the for loop level. So if they are a bit ahead of the for loop, it's going to be considered within the for loop. So that's why I just need to make sure my commands have been placed on the right position. And now I'm going to just display, and let's see what's going to happen. Okay, where we have, so let's see, we have the count in here, line number 7. So now you can see we have error running in command 7. So let me see where we have, what's the syntax error, where it is complaining, count plus plus. Okay, so how about if we do this count plus 1, will it work? Yeah, so we have altogether 80 files sitting into that folder, right? Now, I'm going to now read this file, and that's where the big data concept and the beauty of the distributed programming or clustering comes into the picture. What I'm going to do, everything remains same. You are familiar with this syntax. I have just declared the variable, and I have mentioned the location. Obviously, I have moved this part file to IT equipment. Right, so that's the file, and now this will work. So that's funny, like, in the programming, because what I'm going to do, I'm going to mention all these files which are starting with part underscore, read those files. So you can imagine all these files, and if you remember previously, I mentioned one thing, that most of the time, some of the metadata is sitting within the file name. So we use the file name to extract some part of the information that can later on use within the ETL. So I know that all my JSON file, they are starting with part underscore. I can create different convention based on my ETL requirement, and then based on that, I can build the ETL routine. So that's the syntax. Every file which is starting with part underscore, it's going to be read by our Spark read command. And then obviously file type is going to be JSON. We are asking Spark to detect the schema based on the value, and obviously the first row is header, like we have seen in the sample file, right? And that's why this, looking at the sample file is always helpful. Like, it give us a sense check that what kind of file we are expecting from the system, so we can build the ETL based on that. All right, so now if I come in here and let me just run it. So all the variables have been defined. If you remember previously, that's the way to define the variable. And by the way, guys, I'm working now in 3 different languages. On one side, I'm using Python. The other side, I'm using Scala, which is I'm using for Spark. And by the way, if you don't want to use, I can convert it into Python as well. It's very simple, and have a look how quickly I'm going to actually convert it. All I'm going to just put Python, and that's it. The language, the cell language has been changed. Sorry, I'm just going to. The comments are going to be changed from double backslash to number sign. And like I mentioned, Python is very flexible. It doesn't need any keyword like val or, data type. It just needs the variable and the value. That's how easy it is to convert the Scala language into Python. Now we have defined all the variables. Next command, we are going to read all the files. It's not one file. We are going to read all the file. We can even specify particular files if we want to, but in this case, we are going to read all the file and we are going to construct our data frame based on those 80 files. So everything remains same. Yeah, like you can see, I haven't changed anything. And that's the beauty. Based on the file location, whatever value you put in, that based on that value, the Spark engine is going to read the data and construct the data frame. So let's see how it's going to construct it. And you can see now the Spark job has started, and it is now reading all the files, and based on that, it has allocated the jobs based on the workload. Unfortunately, we only have one cluster with one node, so I cannot show you how it actually distributes into multiple executor, because we only have one node, which is driver as well as the executor. But it still has splitted it into multiple jobs, so it can run in parallel, so it can extract it. And by the way, if you want to see the detail, you can click on the view, and that's the beauty. You can see all what is DAG, what is event timeline. These are all the advanced topic we're gonna see once we are very comfortable using the DataBricks, and we are comfortable using, all the commands. We'll come into it, and especially that is the topic of the optimization, because currently most of the data engineers in the industry, they are facing a lot of challenges. One, the data size goes really big, like we are talking about 100 millions or even billions of records that they need to read out. That's where they are struggling to improve the performance of the cluster. Keep in mind, guys, although we know we have unlimited resources in the cloud, but still we are limited, because obviously in the cloud, everything costs you fortune, right? So you need to be very careful. You need to put the architecture in a way that is cost optimized, right? Many people think, oh, we have unlimited resources. Yes, you have unlimited resources, but that come with high fortune that costs the organization, right? So make sure you calculate your numbers beforehand, before you spin up the cluster, and before you put the configuration into the production environment, because sometimes it hurts badly. It hurts, it consumes a lot of budget unnecessary, that can damage your future, project work item, because you have already blown up your budget on the early stages, right? So that's something you need to keep in mind, especially if you are working from the architecture side as well. So that has been finished without any error. So that's good that we are done. I'm not going to run this one. Partition, I'll come back. That's something I want to show you. So let it run. So you can see it is going to read all the files. It has already read all the file, and it is now counting all the records that has been actually stored within the data frame, read from those 80 files. And I forgot to actually, let me change it in here. So you can see how quickly it is extracting the records, and we have total 6.2 million records. Voila, guys, we have extracted 6.2 million records out of 85. Welcome to big data world, right? And you can see how quickly it just took, 29.82 second. Keep in mind, I'm using the free version of DataBricks with limited resources, but I'm still getting, you know, such a great performance. Like I'm getting everything, and it's not like I have stored it in an optimized format. I'm reading it, the JSON file, which are sitting on my file system, right? And it has been constructed, it has been, a data frame has been constructed based on all these files. So the introduction towards the file system, how we handle or manage the file. Have a look, go through the DB utils library, try those examples, try this example if you want to. It will really help you to understand and you know build your skill, especially from the Spark or Python perspective, because that is one of the skill which you're gonna expect in all kind of, you know, current jobs for the data engineering. Additionally, we have seen the power of using DataBricks and how it really handle all kind of, you know, unstructured or semi-structured data. We are using JSON in this case, and we have seen that how quickly it read 80 files and you know construct the data frame based on 6.2 million record. In the next video, we're gonna use this data set for further processing. We're going to see how we can transform, how we can run, you know, aggregation on this 6.2 million record. And guess what? In future, one of the video we are going to use 100 million records for one node cluster. So hopefully it will, this video will benefit you. Please like and put any comments if you want to know further, or if you have any question. Otherwise, thanks for watching, and I'm gonna see you in the next interesting video.